The lower quartile? Okay. So that means I need the middle of the lower half. I do not include the 98. It's been used. This 98. This 98 is still there. So 1, 2, 3, 4, 5. Ooh, I have 6 of them, right? That means I have to add them together and divide by 2. So the 77 and the 84, I need the absolute middle of those guys. So if I add them together and divide by 2, it's 161. So it's 80.5. So 80.5 is the lower quartile value. I'm going to have to do the same thing for the upper. So I'm going to add these two things together and divide by 2. 336, 118. Okay, 118 is the upper. And then my lowest extreme was 71, and the upper extreme was 164. I'm now going to plot these 5 pieces of information on my number line so I can draw the box and whisker. All right? So here we go. My lower and upper extremes are pretty easy to get out of the way, so I'm going to do those first. So I would have a 71 right here, and these are by tens, so this is 160, 165, back it up a smidgen is 164. Okay, that part was easy. Now, the median is the 98. That's the one that gets the straight line because it's smack dab in the middle. So 98 is very close to a 100. He's going to get the actual line, so I know my box is going to be built around that part. My lower quartile is almost an 81, so it's close to 80, so 80.5. That's going to create the bottom part of my box. And 118 will be right there. That will create the upper part of my box. The whiskers. There we go. Now, what do you notice about how this box and whisker is displaying any of the information? Anything? What do you find kind of interesting about the way this one looks? It's not really it doesn't look balanced, does it? So this is good to show with do you remember the word outlier? An outlier from kind of the one that doesn't fit in. He's an outcast. He doesn't really fit in. So I would say the 164 is somewhat of an outlier. You can see it's quite far away from the overall data. Okay. And so what would the range of the inner quartiles be here? What would the range on the inner quartiles be? So I would have 118 minus the 80.5. What would that be? I don't know. I can't subtract. 118 minus 80.5. What? Yeah, someone should put a 118. 118 minus 80.5. 37.5. So the range would be 37.5 for the interquartile range. Okay, because you are going to be asked to do this on some homework. Can you find the mode if all I gave you was the diagram, the box and whisker itself? Would you be able to find a mode, the numbers that occurred most often? Really? If all you had was this picture up here, you would be able to tell me that there were 271s? You wouldn't be able to tell me any real specific information, would you? Would you be able to find the average of all of my numbers? No, because I don't have the rest of the numbers, do I? I don't have any idea how many of them there were. All I'm finding is the middle, and that's pretty much what this is good for. It's good for chunking your data up into groupings, and that's about it. I had a professor in college. I lovingly call him Dr. Evil. I'd never had test anxiety until his class, and then I developed it at the age of 40. So yeah, it was not a good class, but we were doing, the way he graded things was he used this method to determine what your grade was in the class. Okay? Suppose you had a 95, a 93, a 92, a 90, someone had an 88, and then maybe somebody had an 85, 84, 84, 82, 79, and then somebody had like a 73, 72, 70, 68. And let's say that was the number of students in the class. He would sort of use this method and he would cluster your grades together. Trust me, there's all kinds of ways people grade in college. Be prepared, okay? And you can't go home and tell mom and dad you don't like it because they don't care. So, this guy would go, okay, yeah, this looks like a good grouping right here, so this quartile will get A's. Yeah, this group here, they're close to each other, they'll get B's. This group will get C's. And that's pretty much how it worked. Yeah, it worked out really well until I had an A. Well, I won't say I had an A. I was in the upper quartile here in my class. I thought I was getting an A. He said, if you're happy with the grade in your class, you don't have to come in and take the final. Well, as a college student, if you want to get out of a final, that's usually, y'all want to get out of a final, right? I'm like, sweet, I'm good with my A. I'm in that upper group. Life is good. I didn't go take the final. Well, evidently enough people did go take the final. And guess what happened? Evidently, some of these people moved up into this group, and these people might have gone a little higher. I was still sitting here because I didn't go take the final, and guess what? I was pushed down into the next grouping. I ended up with a B. I was not a happy camper. I know, but I thought I was getting an A. If I thought I was going to get a B, I would have gone in to take the final. So just FYI, figure out how your teacher's going to give your grades before you decide not to go take the final, okay? Because had I known that's what was going to happen to me, I would have gone in, and maybe just me showing up, I might have stayed at an A. Maybe it was an attendance thing. If you showed up, you got to stay where you were. If you didn't show up, you went down one. I don't know. I don't know how he did it. But anyway, so that's that. So that's my life lesson to you at this point. Yes, sir. Did you have a question? No? Okay. Let's look at stem and leaf now. This is pretty straightforward. Most of you have done this before. How many of you have truly never seen stem and leaf before? I've had 2 or 3 in every class. Okay. All right. Stem and leaf is really useful. It's real quick, and it is a very good visual way to represent data. Here's the data that's been given to us. This is the speed of 20 animals and how fast they can run or go or fly or whatever. Okay? If you build a stem and leaf, you have 2 parts. You have the stem side, and then you have the leaf side. The leaf side is always your ones digit. It's always a ones digit. The stem side could be a tens, it could have the hundreds, and we'll get to that in a minute. So you look at the data, and you build your stems. So if you look at this data, did I have anything that went 10 miles an hour? No. 20 miles an hour? No. 30 was my beginning, so I would put a 3 for the stem. That's the tens digit. I had some things that went in the 40s. I had some things that went in the 50s, the 60s, and the 70s. You put them in order from least to greatest. Then you go back and you build the leaves separately. So the way you would read this, show me who you are again, who's never seen this before. So I make sure I'm making eye contact with you, so make sure you understand it, okay? Okay. So the way you would read this is saying, okay, this is the stem and this is the leaf, so this represents the number 32. So I have one number 32, I have another 32, I have a 35, a 35, a 35, I have a 36. So if you needed to write all the data out, that's how you would kind of undo it. So how many animals go 35? 3 of them. 3 of them, because I had 3 5s, so I had 3 animals that went 35. Can you tell what the, and notice that these are in order also from least to greatest, from left to right. What's the mode of this? No, the whole thing. 40. I had 4 animals that went 40, so that's the one that happened most often. Okay? From a stem and leaf, you can also find the very smallest or slowest animal. It went how fast? 32, and the fastest animal went 70. So it's really a user-friendly display of information. Would you be able to find the average? Yeah, you would just add all these values together and divide by however many there were, right? So it's a really good way to represent data. If for some reason, though, you will have more than just a tens column, like here I have 117 and 119 or a 211, you will always, your leaf will always be the ones digit and your stem will be everything else. So that's why the stem here would be an 11, and I would represent 117 with an 11 here and a 7 here. 119 would go here. The ones digit here is a 1, and so the stem would be the 21. Does that make sense? It's pretty straightforward. Let's see if we can build a stem and leaf plot real quick for the information that was on our try it just to the left of this, where we did the big number line with everything. Let's build a stem and leaf with this one. The upside is our stuff's in order already. So here's the stem, here's the leaf. Stem needs to be in order from least to greatest, so what would my first stem be? A 7, good. And then an 8. Do I have any 9s? Yep. I have a 10. I have an 11. I have a 12. I don't have any 13s. I have a 14, and then I have a 16. Now I just have to go put my leaves in. Okay? So I have a 1, and a 1, and a 7. Notice there are no commas or anything. Yeah, you don't need to put any commas. It's assumed that it's a single digit, and so you don't need to separate them with anything. And then on the 8s, I would have an 8, 4, and a 5. I'd have a 98 and a 98. I'd have a 104, a 111, a 114, 122, 147, 164. You okay with that? Seem like it's going to be okay? All right. Do you have any questions? No? Okay. All right. On your homework, I'm going to real quick kind of pass it out and kind of help you with a couple to kind of get the hang of it. And then we will let you do your thing.
Anything else to that stem and leaf plot? Just we make the graph.
I couldn't hear you.
We just make the graph or whatever.
Yeah, that's it. That's just the table, stem and leaf table. And now I could have asked you what is the mode of this table, right? You could have told me, I would hope.
No need, so
Okay.